Children, welcome back to part 2 of a force on a current carrying conductor when it is placed in a magnetic field. Children, we want to know the direction of a force, in which direction the force is acting. So, there comes a simple rule called Fleming's left hand rule. Isn't it, children? The Fleming is a scientist who has given this rule. Means, in order to find the direction of a force, he stated this simple rule. Then, what is this rule tells us? See, children, Fleming's left hand rule says that when we take the first three fingers of our left hand, if we stretch the thumb finger, index finger and the middle finger of our left hand, each finger will give one variable's direction, children. Here, isn't it, children? That is, the middle finger, this will give the direction of a current, flow of a current, whereas this index finger will give the direction of the magnetic field and the thumb finger will give the direction of a motion or force acting on the conductor. Once again, shall I repeat the rule, children? Okay. Fleming's left hand rule states that when we stretch the thumb finger, index finger and a middle finger of our left hand such that each one of them should be mutually perpendicular to each other. See, this is perpendicular to this. This one is perpendicular to this. If these are all perpendicular to each other, then the middle finger, ring finger will give the direction of the flow of a current and the index finger, isn't it, children? If you want to point anything, means which finger will use? This index finger. This will give the direction of a magnetic field and the thumb finger will give the direction of what? Force or motion acting on a conductor. And here simple logic we can use in order to remember during exams, children. Simple, children. F, that is father, mother, child, or in brief you can remember it as a FMC rule. Here F stands for, that is force or motion, then M stands for magnetic field and C stands for current. Isn't it, children? FMC means, if you imagine this as a father and this index finger as a mother and the middle finger as a child, that is father, mother, child, you can easily remember which direction the finger will give. Isn't it, children? For example, father. Father means you have to keep it in mind that this is a direction of a force or motion. Suppose if we say mother here, mother means the direction of the magnetic field, isn't it? That is index finger. Suppose if we say that is child, means it is the nothing but the direction of a current. It is very simple, easy trick in order to remember. That is father, mother, child means force or motion that is given by the thumb rule, that is thumb point, thumb finger. You can take even brief here, thumb, and magnetic field means index finger, and then current means middle finger. Isn't it, children? This is what Fleming's left hand rule. So in the before activity, that is previous activity, the rod was something like this, isn't it, children? The current is initially flowing in this way. Say this is what? Flow of a current. Means how we have to keep now our fingers? That is, we have to apply Fleming's left hand rule, no? Yes. The flow of a current was given by middle finger. This is what? Middle finger now. Then magnetic field is what? Up one, isn't it? This is what? Magnetic field. Then force is which direction, children? Towards left. The thumb is what? Force here. It is what? Towards left. Got it, children? How easily we can apply Fleming's left hand rule here, isn't it? When we keep our left hand in this way, this middle finger is giving the direction of a current, whereas the index finger is giving direction of a magnetic field, and the thumb is giving the direction of a force. Got it, children? Okay, now one simple problem we will solve. By doing so, you can understand this rule in more easier. Children, imagine that an electron enters a magnetic field, means electron is entering a magnetic field at right angles, means the electron is moving perpendicular to the magnetic field as shown in this figure. We need to find the direction of a force acting on it, isn't it, children? Their options also given. How it is moving, means the direction of a force is towards left or to the right or into the page or out of the page. So in order to find this, we need to use a simple Fleming's left hand rule here. What this rule says, the thumb is giving the direction of a force, the index is giving the direction of a magnetic field, and the middle finger will give the direction of a what? Current. Isn't it, children? So children, when we say electron, what comes in mind? That is what? Negative charge. Isn't it? Always the flow of a current is taken opposite to the flow of an electrons. Isn't it, children? If electrons are moving in this way, means then how the current is flowing? It is what? Upward direction. Got it, children? Always the flow of an electron means it's the direction of a current will be to its opposite, isn't it? Means now the flow of a current is upward direction. Now we have to apply here Fleming's left hand rule. That is this finger, that is here, which is current finger, that is current direction, it will give what? Middle finger. So if we keep our middle finger up and the magnetic field is in this way, isn't it, children? The current is moving up. If the magnetic field is perpendicular to it, then what is the thumb? How it is showing, children? It is moving into the board here, isn't it? This is what? Into the board the force is going. Means the direction of the force is now into the board. Suppose if we take a paper, then what it is? Into the page. Isn't it, children? So the direction of a force is what? Into the board. Suppose if it is according to the page, if they have given, means you have to write into the page. Got it, children? How easy in order to find the direction of a force. What we did, simply we had stretched our fingers according to the Fleming's left hand rule. What we did, the magnetic field, we have kept the magnetic field finger towards that, and the direction finger we have kept in this way, in this, because the upward direction will give the flow of a current. So we have pointed here, and the remaining, that is thumb, is giving what? The direction of a force. So how it is? It is going inside the board, means into the board or into the page, the direction of a force is acting. Got it, children? So by these means by the same way you can solve even other numericals. Got it, children?